Alright, today we're going to deal with adding and subtracting radicals, and the very first thing that we have to do is that we have to make sure that we know what the like radicals are. It's pretty much the same as working with polynomials when we dealt with the like terms. So for example, square root of 2 and 3 times the square root of 2, they are like terms because both of them, they have a square root of 2 in every way. So like radicals are the radicals that they must have the index the same and the radicands the same. If they have this all the same n and a, that means they're like, and you can then add or subtract using the number in front, which is the leading, we can call it a coefficient, but it's actually not a coefficient, but you can. So let's go through that. These are, if they're like radicals, you can add them. If they're not like radicals, you cannot add them. So let's go through a couple of examples. Example 1, let's do 2 root 3 plus 3 root 3. And that's first thing we got to deal with is that, yes, root 3 here, that's like terms, right? They're the same. And excellent. Now we're just going to add 2 of these plus 3 of the same. Well, we have 5 root 3. And that is it. All right. Let's do another one. Six root 2, apologies, let's do it with the blue. 6 root 2 minus 4 root 2 plus 2 root 2. All right, first thing we got to deal with, make sure we identify like terms, yes, or like radicals. They all have like the root 2's, like radicals. Now we can go through. So 6 minus 4 and plus 2, so that would be, so in this case, what we can do is basically do one thing at a time. That would be 2 here, because 6 minus 2, and then we have adding another 2 to it, so plus 2. So together we have 4 root 2 after we do the math in here. All right, let's look at another one. This time, let's look at 3 root 2 plus 2 root 3 plus 4 root 5. We want to simplify and add these radicals. Okay, the very first thing we got to deal with, we want to make sure there are like radicals. Are there? Well, this one is root 2. This one is root 3. And this one is root 5. They are not the same. Neither one of these are the same. So you cannot add them because they are not like radicals. They are unlike radicals. All right, so the answer to this is itself. So the answer is 3 root 2 plus 2 root 3 plus 4 root 5. You cannot add them together. Simple as that. All right, and sometimes questions show up where they don't actually look very pretty right away. You have to actually manipulate it so that you can see if there are any like radicals or not. So let's look at this question. Excuse me. So root 18 minus root 2. Now right away if you look at it, so they're not the same, so that we cannot subtract. We've got to be careful. The first thing is that you have to simplify each of the radicals as far as it can be simplified. Then we can say if there are like radicals or not right radicals. All right, so square root of 18, can we simplify that? Sure we can. This is the entire radical. We can change that to a mixed radical. And in here, when you change it to a mixed radical, that becomes 3 root 2 minus root 2. Now 3 root 2 is root 18. Now if you've forgotten how to do that, let's go, make sure you go back to the very first section of changing entire radical to mixed radical and vice versa, and then do that. And now you notice that, we do have root 2 here, root 2 there, and it doesn't have any number in front here, but if it doesn't, that's just 1. So 3 minus 1, it will be 2, and then root 2 is the same, so we got 2 root 2 as a final answer. So it's very important when you see a radical, make sure this is in a very, very simplified form before you decide if there are any like radicals in that expression. All right, let's look at another question, and this one, 2 root 98 minus 5 root 8. Can we do that? All right, same idea again. These are not, they don't look the same. They are not, by first time that you look at it and say, oh, they're not like radicals, but we got to go through and we have to simplify them. All right, so let's do that. The 2 outside, we're going to leave it alone. That's not going to change. Actually, I'm going to change it to the black color that we already have. So 2 is the 2 right here. But the root 98, well, that is, the 49 is a factor of 98 and it's a perfect square. So will be, so this would be 49 times 2. I'm just going to do it once, and then you can see how it's going, and then I'm not going to do it again. So the 5 comes down, and root 8 is 4 times 2. Now again, factors of 8 and factors of 98, and one of the factors must be a perfect square factor. Now you can simplify. All right, so let's now go through and simplify these. So 2 is outside, 47 is 49, square root of 49 is 7, so times 7, that comes out, and then that becomes root 2 inside, minus 5, 4 is going to come out, that becomes 2, and then root 2. Now let's polish that. 14 root 2 minus 10 root 2. Excellent. Now we can say that is 4 root 2, because root 2 and root 2, that they are like radicals. All right, just for the reminder, we want to make sure if you have, so this is a reminder. If you have a square root of a plus a square root of b, that is not, no, equals to square root of a plus b. All right, it is not. You can actually do the example and you can see what I'm talking about. Square root of 4 plus square root of 3, it is not, no, equals to square root of 7. So make sure you know that that is not true. You have to have like radicals in order to add or subtract them. All right. All right, it's now for time for you to get many questions done. Practice, practice, practice. The more you do it, the faster you get. All right, and hang in there. You're doing great. Fantastic.